Hello, class. All right, let's do one last big periodic table. So I wanted to show you what your final product was going to look like so that you know how much space you're going to need. And you guys may or may not have this exact periodic table. So if you need to put any of this top stuff, the 8-man that we worked out on the back, that would be perfectly fine. So if you need to pause it, you could just color it how it is, or you can follow along with me and I'll describe everything as we go. So we're adding just one more thing to this one that we haven't done yet, and that's the reactivity of metals. So you'll get a little half sheet in class. We're going to talk about where you can go on the periodic table because we know there's trends on the table to find where the most reactive metal is and the most reactive non-metal. So remember that sodium chunk that was thrown in the pond? That's a very reactive metal, right? But on the periodic table, follow your purple highlighting, and that's where I've circled your most reactive non-metal and metal. So sodium is somewhere over here, but your most reactive metal is going to be all the way down at the bottom. So this will be on your Friday quiz, and I'm going to give you a periodic table, and I'll give you some choices, and you'll have to tell me which one would be the most reactive out of the options that I give you. So to find the most reactive metal, you're going to go all the way to the left and all the way down. So let's say I give you this choice or this choice. Which one's going to be the most reactive? Well, we're going to want to go all the way to the left. So whichever one is the furthest left is going to be the most reactive. Then if I give you this choice or this choice, you're going to want to tell me the one that is the furthest down on the periodic table. So for metals, to find your most reactive one, you want to go all the way left and all the way down. So francium, Fr, is our most reactive metal. When we move to non-metals, it's just the opposite. So if you can kind of find one, maybe you can also find the other one. So for non-metals, we're going to go all the way to the right and all the way up. But notice which group we're leaving out. We're not talking about our noble gases here, because what are they? They are colorless, odorless, and unreactive. They are very stable. So as you go to the left, remember you are not going to include noble gases. You're going to stop at these halogens and move all the way up. So fluorine, most reactive non-metal, and francium, most reactive metal. So now that you've got an idea of what this is going to look like, I'm going to take you through it. So what I would suggest doing is not coloring yet, because it's a little bit hard to color or to write over top of what you colored. So we're going to start with a blank one. I'm going to move this one out of the way now. We're going to start with a blank one, and I'm going to go through and we're just going to start labeling. So there's a few elements across the top that I like to start with when we're labeling, just to give me an idea of where I am on the table. And I always mess up hydrogen, so I'm going to start with hydrogen first and make sure that I color it its own color. So maybe I'll make hydrogen gray today. I will go ahead and color hydrogen, because anytime I'm coloring the alkali group, I always want to color hydrogen. So let me not mess that one up. Okay, so we're going to try to do a really nice job on this one so that you guys have a periodic table that has everything on it that you will possibly ever need to know for 7th grade. And you can keep this in the front of your binder and you can reference it anytime you need some help with periodic table stuff. Okay, so make this a good one. All right, so we've labeled hydrogen. Let's slide this way. And I'm going to label it hydrogen group. So I'm going to draw me a little arrow to it. You know how I like my arrows? So I like these totally blank ones because I can write on the table. So let's turn this thing and let's start labeling our groups. So I'm going to turn it this way. It does make it a little bit harder to see. Maybe sometime I'll have one without these lines in them. That'll be my next goal. All right, so you ready? We're going to write group 1, alkali, A-L-K-A-L-I. Alkali metals. I'll see if I can zoom a little bit. All right, alkali metals. Group 2, alkaline earth metals. Okay, so now that they're labeled, let's see if we can go back over and write a little description of each one. So we're going to say alkali metals, most reactive. That's the sodium in the pond example. For the alkaline earth metals, since they're the second group, they're still very reactive, but they're the second most reactive. Okay. I'm going to turn back around now for the transition metals since there's so many of them. They grow from group 3 all the way over to group 12. But there are quite a few characteristics about them that I want you to know. So we're going to say transition metals. These are going to be common. So they're things that we know: silver, gold, nickel, aluminum, copper. They're going to be good conductors of heat and electricity. We use that word malleable a few times in class. Let's make sure we know what that word is. M-A-L-L-E-A-B-L-E, malleable. And that means they can change shape easily. So if they can change shape easily, like an aluminum can, you can crush it. You can bend copper into wire and tubing, and it won't break apart or fall apart. And speaking of wires, you can also have these transition metals be ductile. D-U-C-T-I-L-E. That means they can be made into wires. Can be made into wires. It is really hard to write when there's squares on here. All right. So while we're here, let's talk about these lanthanides and actinides. So really, move those out because this whole section should be fitting right here. But if we put it there, it would make the periodic table super duper long and it wouldn't fit on a piece of paper. So we just pull these things out and we put them right here at the bottom. That's really just a space saving thing. So the ones on top are the lanthanides. L-A-N-T-H-A-N-I-D-E-S. These are metals. They're shiny and reactive. On the bottom, we have actinides. A-C-T-I-N-I-D-E-S. Actinides are all radioactive. Okay, moving on across. Just because transition metals kind of give me a hard time sometimes, or the metalloids, I mean, let's go ahead and label them. Let's label across the top. I always want to find my aluminum because that lets me know where I don't have a metalloid because I remember that aluminum is a metal. So I'm going to label my BCNOF, BCNOF, and my helium and my neon. It kind of gives me an idea of where I am on the table. So all I've done is just label those. So I do like to color in the metalloids though, so let's do that really quickly. So if we start with our stair step, we're going to know that anything touching our stair step is a metalloid. Let's see, we're going to go to here. Under the oxygen group is where our metalloids end. So I'm not going to color very well. If you need to pause and work on your coloring, you can. I just want to give you an idea. So I'm going to turn sideways just a little bit. And I'm going to write metalloids right across there. All right, so there's my metalloids. Maybe time to write that. At the bottom, I'm going to turn sideways because I have a little bit more room down here. I don't want to use the space up here because that's where we're going to write our electron dot diagrams. So we're just going to label the BCNOs. So we're going to label boron group. And I'm just going to put GR, so I don't have to spell it out. Carbon group. Nitrogen group. And oxygen group. So that's going up and down, even including the metalloids. So if you're talking about boron group, you would include boron and everything further down. If you're talking about the carbon group, that's carbon and everything else in that vertical column. Same with nitrogen and oxygen. So these groups do get complicated because you've got some metals at the bottom, metalloids in the middle, and then some non-metals up at the top. So the characteristics of these groups are a little bit complicated. So let's move on. I'm going to turn back sideways. Give you a chance to write that. I'm going to keep going with the halogens. HALOGENS. So halogens are unique. They can make salt when combined with metal. So that's our table salt, NaCl. So halogens can make salt when combined with metals. I'm going to run out of room on halogens. There's a lot to say. So can make salt with metals. That's our table salt. And then we're also going to say that they are very reactive with group 1. So I've crammed that in there. Very reactive with group 1. So when you do the W and the slash, kind of a note-taking strategy. And then our last group are the noble gases. And these noble gases are the nons. So there's 3 nons about them. They are unreactive, colorless, and odorless. Odorless, ODORLESS. Something else about these noble gases is that they have a full outer shell. What does that full outer shell do for them? It means that they are stable and that they do not bond with other elements. Find them alone. Okay, so I'll give you another minute just looking at that. Pause it if you need to. I'm going to go ahead and move on. Let's go across the top and let's start labeling our groups. I'm going to start back over here on the left. I'm going to fill in lithium and beryllium, just so that I know where I'm at. Okay, so the first set of numbers I make across the top is going to be the group number. And I'm going to pick one color with that, so I'm going to stick with black and then I'll switch in a minute. So group number 1. $12 takes me to the end of the transition metals. Okay, so now I'm going to switch colors, so I'll label my groups. And now let's go across the top and let's label what our valence electrons will be. So anything that we do in valence, I'll do in a different color. So first we're just going to do the valence number. So show me how you would count across the periodic table if I asked you really quick to describe or tell me what the valence number would be for any element. So you would say 1, 2, and then what do you do here? You do the skip a few, and then we pick back up with 3, 4, 5, 6, 7, 8. Okay, let's go back across and let's do our valence electron dot diagrams. So let's do a dot diagram, the Lewis diagram. So we'll start with hydrogen. Hydrogen has 1 top. Remember, we go top, bottom, left, right, and then back around clockwise if you have to fill it up. We'll take beryllium, top, bottom, since it has 2. Going across the table now, we skip transition metals, and we're going to say boron, top, bottom left. Carbon needs 4. Nitrogen gets 5. Now something I want to remind you to do over here, let's do helium and neon because I want you to see the difference. Helium, its atomic number is 2, so it's only going to have 2 electrons. But with 2, that still means it has a full outer shell, even though it has 2. And then let's see if we can squeeze neon. I've not left a lot of room. But neon's going to have 8 valence electrons, so neon gets 8. So whether it's 2 or 8, they both are full. Full outer shells, no matter the number. Okay, I'm going to throw a little color back over here on the metalloids because they can get a little confusing. So we're going to take anything that is not a metalloid, but that's not a transition metal, and let's color that in. So we're going to start with aluminum. Again, you can pause if you want. We're going to color all of these in. You can take a second, do a nice job coloring. Okay, make sure you color better than I do. Okay, so these down here, we're going to label these post-transition metals. You will not have to know that on any quiz that I give you, but that might be something that you'll need in high school. So if you know the word post in maybe your ELA class, if you use it as a prefix or something like that, post is going to mean after. So we have the transition metals. Then we have the metals that come after them. So they're the post-transition metals. So these are still metals down here on the bottom. And then up here on the top corner above the metalloids, we're going to still stay in that oxygen group. Again, you guys do a nice job coloring. I'm going to rush mine just for the video. And these are just going to be called nonmetals. So I'm going to turn my paper sideways a little bit, and I'm going to squeeze that in right here. Non-metal. So any of those gray are nonmetals. Okay, so we said earlier we were going to talk about reactivity in this video because that's something we haven't done yet. So super simple. You're going to love it. I'm going to grab a highlighter. I think I'll stick with purple. All right, so we're going to go right here. We're going to circle fluorine a few times, make it really stand out, you guys, so you can find it quick. And we're going to come all the way down to the bottom left, and we're going to circle francium, FR francium. We might even want to fill this in that it's francium, so put that in the bottom corner if you want. All right, on the bottom, I'm going to come down here and I'm going to describe what we just did. So if we're talking about metals, and we're talking about their reactivity, metal reactivity. So if I'm looking for metals, and I want to find the most reactive metals, the first thing I'm going to do is go to the left, and then I'm going to go downward. So the further left I go, and the further down I go, that's where I find the most reactive metals. And then down here, let's just remind ourselves that that's francium. If we're talking about nonmetals, let's make a description for that. So if we're talking about the reactivity of nonmetals, we're going to go to which direction? Yep, so it's just the opposite. So instead of going to the left, we're going to start going to the right and up. So our most reactive nonmetal will be fluorine. And just to help color code so we can find things quickly, whatever color you circled these in, let's come down here and highlight these words with it too. That way all reactivity information is in the same color, and that makes it easy to spot on your page of notes. Plus it makes it colorful, and that's just more fun. All right, so that's what that should look like. Okay, just to remind ourselves over here on the side, one final time, when we talk about groups, we also mean families, and that they move up and down. They are vertical, and there's 18 of them. When we talk about a row, we're talking about a period, and that they move horizontally, and there are 7 of them. So we can come back over here. Let's see, pick a totally different color. I'm gonna use pink. I'll go over the number 7 here with pink. So I'm gonna come down the side and just number my rows. Okay. Rows are numbered, groups are numbered, valence electrons are numbered. We are moving along quite nicely. We've labeled our most reactive metals and nonmetals. You guys can color after. So let's go back up to the top and let's tell everything we know about 8-man and how we can describe anything about an element on the periodic table just from the top and bottom number in the box. So just for today, I've picked beryllium. So let me show you again what we're going to do. So we're going to be working at the top. We're going to describe 8-man, so leave room to write these words. We're going to draw the box and label it. We're going to draw a Bohr model. And then I didn't do the dot diagram, but we will. We'll come over here and do the dot diagram too. So you're going to need quite a bit of space. If you don't have this space, just flip over to the back. You may have a different table than I do. All right, so let's get started. Across the top, when we say ape, we say A equals P equals E, right? That's plenty big enough. And then when we say man, we're going to subtract. Ape, man. I'm going to turn my paper to the side and let's describe what those things are. So A stands for atomic number, P for protons. Protons are positive, and E for electrons. They are negative. So always try to stick those signs in there for what charge they are. M is for mass number. A again for atomic. And N for neutrons. Remind ourselves again that neutrons are neutral. They have no charge, so they do not change the positivity or the negativity of an atom. Okay, give you a second with that. Pause it if you're still writing. We'll move on. All right, so we're going to draw the box for beryllium. So beryllium, 4 is its atomic number, 9 is its mass number. So for the 4, that's the atomic number, and our trick to remember which one's on top of the box is that the atomic is atop. We're going to write everything on this paper today for one last time. You can do it. Stick with it. Remember, mass is heavy. It's at the bottom. Okay, so let's come over here and let's describe the ape. Oh my goodness, I'm trying to write the wrong thing. Sorry, scribble. Got ahead of myself. So if the atomic number is 4, that means I have 4 protons and 4 electrons, 4 positive protons, and 4 negative electrons. If I want to come work man, if I can fit that here, M minus A equals N. So what's my mass number? I'm scribbling all over the place. Sorry, guys. So if my mass is 9 and my atomic number is 4, I will subtract that and it'll give me 5. So I have 5 neutrons. So we're going to come up here to the top and we're going to write down everything we have so far. So for beryllium, let me zoom. For beryllium, oh, we don't want to wiggle. For beryllium, I'm going to have 4 protons. 4 electrons. 5 neutrons, and we're going to go figure out our valence electrons. So you can do valence electrons a couple of different ways. Do it the quick way, always. Count across. Beryllium's in the second group. So how many valence electrons does that mean beryllium's going to have? 2. Let's make sure. You can also draw the Bohr model. So Bohr model. We're going to put Be in the nucleus. We won't try to draw protons, neutrons. We're running out of space. But put beryllium in your nucleus. And how many total electrons did we have? 4. How many can I fit in my first level? Just 2. So that means I'm going to have to add another level. If I have 4 total electrons, I've used 2. So I need 2 more. And that does mean I have 2 valence electrons in the outer level. And then the dot diagram for beryllium would be 2. 1 on top and 1 on the bottom. And that's my Lewis dot diagram. Look how much you guys have learned in such a short amount of time. Okay, so we're still not finished. So where are all these things found in an element, in an atom? So we have the protons. When you guys did your element builder, where does the mass come from in an atom? That's right. It comes from the nucleus. Nucleus is like the marble. Marbles are dense. So protons and neutrons have the mass. And then the electrons are floating around that nucleus in the cloud. So electrons have mass, but not that much compared to protons and neutrons. So I believe, guys, that is it. That is what you've learned about the periodic table. So I'm going to end this video going back to my original one, so that you can have one to look at in color. Actually, okay, we're all done. Good job, guys.